All right, today we're doing the Glacier Lab. This one's a pretty straightforward lab. I'll kind of refer to it up here. All right, so the first page here, you just have a little intro about glaciers. You got a bunch of vocab down here. You do have to do the vocab on this lab. Next page. You just have fill in the blank. You got a word bank here about various glaciers things, and you just have to fill in the words here with the appropriate word bank. Part 3, how tall are the glaciers? So what you have to do here, it talks about how tall the Empire State Building is and the height of the last glaciers. So what you're going to have to do is figure out how many times greater is the glacier than the Empire State Building. So the math there is fairly simple. I don't think you have a problem with that. All right, here, these are a bunch of features that you'll find at the edge of a glacier. This is the same diagram that's from your notes, so basically you just have to label what features are what from that word bank. Right here are just some pictures of some various glacial features. So here I have a bunch of different sized particles all mixed together. Here I have a bunch of scratches. Here I have a big boulder. And here I have a oval shaped hill where one side's steeper than the other. But anyway, so you have to figure out what the name of these features are from the vocab on the front. Now this part here is probably the only part that really requires much of an explanation. And what we have here is a diagram of 3 Alaskan glaciers. And what we want to do is we want to figure out a few different things from this. First off, what we want to figure out is whether the glaciers are advancing or retreating. An advancing glacier means it's getting bigger and expanding. Retreating glacier means it's shrinking. So that's what we're finding out first off. Next we want to find out is how much did it advance or how much did it retreat. And then we're going to figure out how fast it's advancing or how fast it's retreating, and then try to figure out where the glacier would be today based on the data we have. So I'm going to do the Shymkiw Glacier all the way through to show you how to do it. And then the other 2 glaciers, it's the same procedure as I'm going to do here, but it's just for the other glaciers. All right, so the Shymkiw Glacier, all right, the big one in the middle right here. And first off, we got to figure out whether it's advancing or retreating. Well, on the diagram here, it shows you where the glacier was in 1948. And the most recent data here is where it was in 1998. So if that's where it was in 1948 and that's where it is in 1998, you can see the glacier's getting bigger, so the glacier is advancing. I'll just put EDV. Okay, next, we want to figure out how many miles is the glacier advancing, all right? So what I want to do is I want to measure that distance from A to B, using the scale right there. And take the edge of a piece of paper and mark it from the A to the B. I come to my scale, And I can see that distance right there from A to B on my scale is pretty much 2 miles right on the dot. So the distance that the glacier advanced was 2 miles. All right. Now, how much time went by? Well, this is where it was in 1948. That's where it is in 1998. So if I do 1998 minus 1948, there's a difference of 50 years. So it took 50 years to go from there to there. Next, the rate at which the glacier is advancing. All right. So the rate's going to be the distance divided by time. So this glacier advanced 2 miles over 50 years. So if I do 2 miles divided by 50 years, punch that into my calculator, that would work out to be 0.04. Right? So that's the number, it's going to go right there. 0.04 miles per year. All right. Next, time to present. All right. So the last data I have on this glacier here is 1998. The current year that I'm doing this is 2021. So what I need to do is figure out how many years difference are there between 2021 and 1998. So I go 2021 minus 1998. Subtract those two, works out to be 23 years. All right. All right, so there's been 23 years since this diagram until today. Now lastly, we want to predict the predicted distance. So basically we want to figure out where, based on the data we have, where is the glacier now? So how we go about doing that is, if it kept on, I'm going to extrapolate my information I have here, is traveling at a rate, is expanding at a rate of 0.04 from 1948 to 1998. If it kept going that rate for 23 years, I want to see how far it would have moved since then. So what I need to do is take the 23 years and times that by the rate of 0.04. So 23 divided by 0.04, that would work out to be 0.92. That times that is 0.92. And that distance would be in miles. All right. So what that would mean is that if this glacier was kept on advancing at that same rate, that this glacier would now be 0.9 miles over here someplace. All right, so then you're going to do the exact same thing for the Norris Glacier over here, and the exact same thing for the hole-in-the-wall glacier up there. All right, so that's what you have to do with that map. All right, next page. There's background info about those specific glaciers, and you're going to answer the questions based on the background info and this map right here. All right, now, some of the questions involve doing latitude and longitude, and just a little, this is actually the same glaciers as from the previous. It's a different map, but it's the map of the same area, the same glaciers. But what we want to do here is just some questions that involve using latitude and longitude. and the latitude numbers are on the side there, the longitude numbers are on the top. But just as a little quick review, so the number down here is 58 degrees, 0 minutes. Up here, that says 58 degrees, 20 minutes. Now, it doesn't say whether it's north or south on there, but I should be able to tell whether it's north or south just by looking at the numbers. And how I know whether it's north or south is that's 58, that's 58.20. So that number right there is bigger than that number right there. So what that means is that it's counting up this way, so the equator has to be down here someplace. So both of these latitudes, even though they're not labeled as such, both of these latitudes would have to be north latitude. All right. Now on the top here, right here, I have a longitude of 134 degrees, 0 minutes. Over here, I got 134 degrees, 10 minutes. And again, it's not labeled whether it's east or west longitude, but I could figure that out since it's going from 0 to 10. It's counting up this way. That means the prime meridian would have to be over here someplace. That means I'm counting west of the prime meridian. So even though those two numbers aren't labeled as such, they would both be west. All right. So there's a couple questions that deal with having to describe the latitude and longitude of spots on the map here. All right. And lastly, there's just some questions that are just some multiple choice questions on glaciers in general. All right. All right. So that is all there is to the Glacier Lab.